All right, we're going to be looking at add, subtract, and multiply radicals. Okay. So we've done some simplifying of radicals that we've done. So now we're just going to start working on some of the operations. Add, subtract, multiply. Add and subtract, pretty basic, and you got to have like terms. I say pretty basic. The idea is basic. Right? We need like terms to add and subtract no matter what. Okay, so think back to this. You know, you can do 3x plus 5x because they're like terms. Okay, yeah, you cannot do 3x plus 2y because they're not like terms. Okay? So when it comes to radicals, the radical is what determines if it's like or not. Okay? So that means that if I had 3 root 2 plus 7 root 2, then I can actually add those because they're the same radical. Right? So kind of think of it as an x. 3x and 7x is 10 of those guys, so 10 root 2. So like terms I can add. Likewise, I can subtract, but I've got to make sure that I have them like. I don't even care what's in this radical. Let's say I had 5 root x minus 8 root x. What I care about is the radical's the same, and it is. Okay? So I've got a root x on both. 5 minus 8 is negative 3 root x. Those same pieces. We could have multiple ones. 6 cube root 2 minus 7 cube root 2 plus 8 cube root 2. It doesn't matter how many terms we have when we're adding and subtracting. What does matter is if they're like. And now I went from a square root to a cube root, but they're still all like. They're all the same cube root 2. So you can combine them. So let's see, 6 and 8 is 14 minus 7 is 7. Cube root 2. Look okay? All right. All right. Now let's look at something like this. Let's see. We'll do this. 1, 2, 3. Let's go with some that don't look like. Let's go 3 root 45 minus 7 root 20. Okay. Now these are obviously not like. I don't have a 45 and 20 aren't the same number. But I can simplify the radical. So even if they're not like, I still need to simplify. Think of like fractions. You know, fractions in the past, you might not be able to add or subtract them, but you still need to have them reduced. All right, so we need to simplify this. So we're looking for that perfect square. 45 is 9 times 5. 20 is 4 times 5. So remember from previously when we were simplifying radicals, we're looking for the perfect square that goes in there, not just any number. Like, I know 2 times 10 is 20, but that's not going to help me simplify that thing. I need that perfect square. So the square root of 9 is 3 times the 3 on the outside. So that's what the step looks like. 3 times 3 root 5, which would be 9 root 5. So again, here's this 3 right there. That outside 3. Then square root of 9 is 3. 5 still in. Minus 7 times 2 from the square root of 4, root 5. So there's that 7 sitting there, which would be minus 14 root 5. Now when I look at it, I do have like terms. I didn't in the beginning, and who knows whether I would have or not. I've still got to simplify it. Now I do have like ones. They're both root 5. So 9 minus 14 is negative 5. Root 5. So the basic idea of addition and subtraction, pretty simple. They got to be like. If they're like, I can do it. If they're not like, I can't. Now, sometimes we've got to do some extra work that isn't necessarily so simple to see if they are like. That would be the difference there. So let's go 9 root 50 plus 7 root 2. So again, definitely not like. Okay? That's for sure. I can't simplify the root 2, but I can simplify the root 50. 50 is 25 times 2. So I would have square root of 25 is 5 times the 9 on the outside is 45 root 2 plus 7 root 2. And then 45 plus 7, these two I can add because they're like 52 root 2. Everybody okay there? Okay. One more like that. Let's go 4 root 75 minus 2 root 18 plus 5 root 27. So again, we look at those. Obviously, none of the three are the same. 75, 18, and 27 are not going to be the same value. So we can simplify it, though, and see if we end up with any of the same. So 75 was 25, or is 25 times 3. Square root of 25 is 5 times the 4 is 20 root 3. 18 is 9 times 2. Square root of 9 is 3 times 2 is 6. So minus 6 root 2. That 2 is staying in. And then 27, 9 times 3. All right, so square root of 9 is 3 times the 5 is 15 root 3. Does that look okay? Now we do have like ones. They're not all 3 like, and that's okay. But the first and the third are. They're both root 3s. So 20 and 15 is 35 root 3 minus 6 root 2. And it doesn't matter what order it's in. If you wrote it negative 6 root 2 plus 35 root 3, that's fine. It doesn't matter. But I've got to make sure I get my like ones together. All right. Multiplying. When we're multiplying, sometimes we're going to still have to do some addition and subtraction, but what I want you to think of a multiply, inside with inside, outside with outside. And when I'm saying inside or outside, I'm talking about the radical itself. So we're going to multiply the numbers inside the radical with the numbers inside the radical, and we're going to multiply the numbers outside the radical with the numbers outside the radical. Oh. Let's kind of give a basic one here. Let's go 2 root 3 times 5 root 2. So if I'm going to multiply those two radical expressions, inside with inside, outside with outside means just that. I'm going to multiply the two inside numbers. 3 and 2 is 6. And the two outside numbers, 2 and 5 is 10. So I would have 10 root 6. So that's what I mean by outside with outside, inside with inside. It doesn't matter if I have variables, numbers, it doesn't matter at all. Let's go x square root 2 times x square root 5. So out without, x times x would be x squared. In within, 2 times 5, 10. Now, one of the things that we're going to run into is sometimes when we multiply, we can actually still simplify. So let's think of something like this. Let's go 5 square root xy times 3 square root x squared y. Now, I know I've got some extra stuff going on there, but I'm still going to stick. Outside with outside. 5 and 3 is 15. Inside, I've got x and x squared is x cubed. Y and y squared. And that is the correct multiplication. However, it can be simplified. So for the simplifying, goes back to what we did a couple classes ago. 15's out here. I can pull 1x out, 1 stays in. So remember, 2 square root needs a pair, so 2 goes into 3 one time, 1 left over. 2 goes into 2 one time, the y comes out, and there's my final answer. So if I can simplify, I will. If I can't, it's fine. It's not a big deal. So obviously the first 2 there wasn't any simplifying I could do at that point. This last one there was. Let's look at another one kind of like that. Let's go a square root a squared c times b square root a cubed b squared c. Now when I'm combining these two, I know I added another letter in there. It doesn't matter. I'm going to first put my outside with the outside, and then I'll put inside with the inside, and then I'll see if I can simplify. I'm not worried too much about how good or bad something looks. I'm just trying to get it together. All right, out with out. That's A and B. I'm going to have AB on the outside, square root. All right, in with in. A squared and A cubed is A to the 5th. Then B squared, only had a B in one of them. And then C and C is C squared. Now, yes, I can do some simplifying here, but my goal was just to multiply first. I've got to multiply. So now I'm doing square root. So let's see. 2 goes into 5 twice with 1 left over. So if it goes in there twice, 2 are coming out. Now I have an A cubed outside because I already had 1 sitting out there. So now I've got 2 others. Okay. So 2 came out with the 1 I already had, 1 left in. Now I go to the B's. I'm going to have 1 B coming out. 2 goes into 2 once. 1's coming out with the B that's already there, so that's going to make a B squared outside. No B's left. And then C, 1 C coming out, no C inside. Here's my final. Everybody okay there? Okay, now let's bring in some other multiplication looks here. There's some other multiplication looks. Let's go square root 2 times square root 8 minus 2 root 2. Different look. Definitely not the best look, but let's kind of investigate what we've seen in the past. Okay? This is something, not like that, but this is something you should remember. You know, if you saw something like this on a paper, 3 times 2x plus 5, you should be thinking, okay, that's pretty easy. Okay, I know I can distribute the 3 times 2x, 3 times 5. Pretty basic distribution property. We've done it many, many times. This is the same thing. Looks way different, but same thing. So we're going to distribute that root 2 to each piece. So I'm going to have root 2 times root 8 is root 16, because inside with inside. Minus 2, root 2 times root 2 is root 4. Now I know I can simplify that, but that's my base raw form of the multiplication. Notice I stuck with inside, inside, outside, outside. Now I'll simplify. Root 16 is 4. And this would be 2 times 2, so that would be 4. So root 4 is 2 times 2 is 4. Answer, 0. Okay, let's look at one with an outside number here. Let's go 3 root 5 times 4 root 2 plus 2 root 5. Looks a little worse than the last one because we got that 3 out front, but we're still going to do the distributive property. So I'm still sticking with, hey, whatever's out here, you're distributing to the first one, then distributing to the second one. What I'm making sure of is I'm adhering to outside with outside, inside with inside. So when I look at this first pairing, out with out's 3 times 4. 3 times 4 is 12. Inside, 5 times 2 is 10. I go to the next one, plus 3 times 2 is 6. Root 5 times root 5, root 25. And then I'm looking for anything that I can simplify. There's nothing I can do to the 10. Wish there was, but there's no perfect square that goes into 10. I'm kind of stuck with that. So we're going to have 12 root 10. Then over here, root 25 is 5 times 6 is 30. That's about all I can do. You notice still stuck outside with outside, inside with inside, distributive property. All right, here's another look. Let's go 2 plus root 3 times 5 minus root 2. Now this looks worse and we got kind of a binomial, but let's put some x's back in here. This to you, 3x plus 2 times 5x minus 4. That should look pretty basic review. That's your old FOIL method or distributive property where you're taking this 3 times each one and come back and pick up that 2 times each one. Okay? So we're looking at the same thing in a radical formation. So same operation, different look. So we're going to distribute the 2. 2 times 5 is 10. Minus 2 times root 2 is 2 root 2. Remember, we can't make that a 4 because one's outside, one's inside. Then I'll come back. Comes that root 3 times each one. Root 3 times 5, 5 root 3. Root 3 times 2, root 2, minus root 6. There I've got inside with inside. And that's as far as I can go. There's nothing like terms there that I can put together. I wish there was. It'd make things a little bit easier, but there's just not. Okay? But I've got to multiply. Right, let's go with root 2 minus 3 times root 2 plus 4. We'll get some like terms here. Still think of it. I've got a binomial times a binomial. So I'm going to first distribute that root 2. I have root 2 times root 2 is root 4. 4 times root 2 is 4 root 2. And I know root 4 is 2. But sometimes to have that intermediate step in your notes does help. Come back. Negative 3 times root 2 is negative 3 root 2. And negative 3 times 4 is negative 12. And then I'm looking for some like terms. So on that first one, hey, that's 2. We know that. So I've got some like terms here. 2 minus 12 is negative 10. 4 minus 3 is just plus root 2. Or you can write 1 root 2. 4 minus 3 is 1, but we haven't understood 1 there. And that's as far as I can go. At our last look here, let's go root x minus 7 squared. Threw an x in there, doesn't matter. Okay, so let's kind of review what we saw with just our algebraic non-radical stuff. So if we saw something like this in the past, like you had 2x plus 5 squared. The first thing that we did was we wrote it twice, 2x plus 5, 2x plus 5, and then we started multiplying, but it went right back to what we'd seen before. So when I see this square on the outside, first thing I want to do, even though it's got a radical, there's 2 of them. I'm going to write it twice. And then I'm ready to go just like the last 2 problems. Get it written twice there. So I'm going to have root x times root x. That would be root x squared. Root x times negative 7 minus 7 root x. Come back, negative 7 times root x, negative 7 root x. And negative 7 times negative 7 is plus 49. And then I'm looking for things to simplify. All right, square root of x squared. There's my x. Okay. Negative 7, those are like terms. That'd be negative 14 root x. And then plus 49, there's nothing else I can really do there. I don't have anything else that's like in that point.